again.
Yeah. You would. Yeah. So Internet of Things, which is now known as IoT more commonly. So how does Freescale define Internet of Tomorrow?
So the Internet of Things is everything being connected, adding intelligence to everyday items in your home that normally didn't have intelligence or connectivity, as well as the analytics. So I think that's already starting and really prevalent in a lot of places in the world. What Freescale terms the Internet of Tomorrow is not only the connectivity, the intelligence, as well as the analytics, but also adding security. I think one of the components that still has to be ingrained in every single component of the Internet of Things is security, and Freescale have been providing security solutions inside of all of our processors that fit in end nodes, gateways in the cloud, so you have a continuous stream of communication with security and really securing the whole IoT. And so really the Internet of Tomorrow is a secure Internet of Things.
Okay, my next question is, what are the key marketing trends that Freescale has identified in IoT space?
Sure. I think probably the largest one is the connected car. And I guess it depends on how people define the Internet of Things, but we see the connected car being one of the most, I'd say, visual trends that people can see, as well as if I look at the amount of, or the density of electronics in a car. You have 4 tires. 5 years ago, you'll probably have 4 cars in your car in 10 years' time. You have, about 50 components about 10 years ago in your car, electronic components. You'll probably have 500 in about 10 years. So the rate of change of your car in one very confined space is probably advancing faster than any one industry alone. That's one of the big macro trends. One of the other big macro trends is because of the amount of internet access now needed for the Internet of Things, you have a lot of the communication or the bandwidth, the internet bandwidth, increasing multiple times, at least the need for increasing multiple times. So the processing performance needed by all of the servers, the gateways, as well as the cloud is incrementally or exponentially increasing, which is where Freescale plays with our Core IQ and processors, really increasing the level of performance levels so that we can actually increase the bandwidth across the networks.
Okay. What are the key technologies, the innovative technologies in MCU that Freescale is actually coming up with?
Oh, sorry, could you repeat that one?
What are the key technologies in MCU that is driving IoT forward, and what will be in the future according to Freescale?
So I think some of the key technologies, if I could name 3, it would be the ability to reduce power consumption for MCUs based on performance, not just the absolute power consumption, but it's higher performance with lower power. So it's really power efficiency because a lot of the items that are in the Internet of Things are becoming more portable without battery or without connected power. So they need to last for very long periods of time. But not only that, but they have to have connectivity, and that's the second port. Connectivity a lot of times takes more power consumption than a normal process would. And so what you need now is connectivity like low power Bluetooth or Zigbee that have the capability of running at extremely low power consumption. So you can have a battery and it can run for months and years. And then really the third component is the security, is the ability to stop people tampering, because people normally can physically touch what a microcontroller would go into in your home or in the smart energy or smart city. So the ability to stop people tampering with the device, so it's a lot of security implementations in the MCU device, as well as the connectivity from the MCU device to some form of a gateway, so encryption. So there's a lot of products that we coming out from Freescale, like the Kinetis K80, that are integrating a lot more, I'd say, encryption capabilities, and then across our portfolio, really adding a lot of secure boot, tamper protect technologies, and the inability to be able to touch the pins with a probe and actually read any data from it without you wanting them to.
Okay. Just going by the demos that has been displayed out here in the IoT truck, the major MCU which is being displayed is i.MX6. So I believe Freescale has come up with i.MX7 also in this space. So if you can briefly talk about what the product is capable of.
Sure. So what you're taking is, with the i.MX7, you're taking the i.MX6 to a next level. The i.MX7 is really a lower end processor, and what really lower end means is lower price, lower power consumption, and to be able to get really integrated into embedded devices. And it really goes back to Internet of Things and the needs of Internet of Things products, which is power consumption, connectivity, and then security. And the IMX7 implements multiple different components of those three technologies, as well as performance into that IMX7. And it's really performance per power consumption. So if you look at it, it's really the unit of performance that you can get from the minimal unit of energy needed to drive that performance. I think the other component is a lot of our IMX devices, including our IMX6 UL that's been released, is really driving a lot of multi-heterogeneous processing. So you have a small microcontroller integrated with an application processor, and what that microcontroller does is it turns off the larger application processor when it's not needed, but then just allows it to sense and monitor at extremely low powers, and then turn on the application processor when needed. So it's really all focused on power consumption per unit of performance.
Okay. What are the key technology trends that are making the MCUs more secure in the IoT space?
So there's multiple different, I would say, security technologies that are implemented into MCUs. Some of them would be really the security around the flash on the device, because you have the flash is really the one place where any kind of, I would say, predators trying to get information from your device will go to the flash, because the flash is storing all of the information that you're either reading or that you're writing to different places. So we have multiple different sets of technologies aimed at just directly protecting the memory on the MCU. So we have that. Other components are the ability to actually read, and believe it or not, you can read information from a microcontroller just based on the voltage changes or the power consumption changes externally to external devices on the chip, off the chip, excuse me. So what you're actually able to do is we have a number of tamper protect security capabilities to reduce people probing external pins to test for variations in voltage or variations in power consumption. And we have multiple different security features that stop that ability for anybody to break into the device that way. And then I think the other component, which I mentioned a little bit already, was really around the encryption, which is adding encryption capabilities, because Internet of Things devices are little small devices that now have, you know, IPv6 connectivity to the internet. So you now need network security for those microcontrollers connecting to the internet. You need to, not for all, but for a lot of those end equipments, you need to secure that data all the way to the internet and back.
Anything about the crypto technology related to MCUs?
Yeah, I think the bigger challenge for MCUs is to take crypto blocks like AES, TriggerDES, DES, and actually shrink them down to a very small size that can actually fit in such a small microcontroller. You know, you're talking about 5 by 5 millimeter devices. How do you implement a crypto block into that? And that's a lot of the challenge. The second challenge is the ability to have those crypto blocks run at extremely low extremely low power consumption, which is really one of the kind of key knobs that you need to tune for security capability down at a micro level.
What are the recent advancements or the developments that has happened in Freescale to help engineers create more secure IoT network or services?
Yeah, so there's multiple different components. Like if you look at how many different features that Freescale have from a security standpoint, there's about 80 different features that we have in our processors that are based on securing the chip. Now what we're doing from Freescale in terms of the microcontroller and making them more secure is taking technologies from our processors, like our networking processors, where it is probably one of the most secure devices that you have, available today, because they secure all of the data and all of the banking information and all of the financial data in the cloud. We're taking all of the technologies that have been developed for those processors and then shrinking them down for microcontrollers. So what we're really doing is cross-pollinating all of our security capability from not only our networking processors, but also all the processors we use in automotive, and then using them reusing them inside of our microcontroller portfolio. So it's taking the big library of 100 or nearly 100 different security components and using the ones that we need for IoT devices.
My next question is, how are IoT applications are influencing the change in sensors technology?
So I think what you're seeing for IoT applications is people are coming up with new ways of using sensors. And what I mean by that is, for me in the future, I think that you're going to have a lot of microcontrollers and a lot of processors that integrate every single sensor. And why I say that is you have accelerometers, but an accelerometer in your in a fire alarm or in your fire sensor will be able to feel reverberations of smoke, will be able to feel reverberations of movement in your house based on wood shrinking and cracking based on heat, even if it's not directly getting smoke. So there's a lot of sensing technology that you can use in every single product that the functionality hasn't been brought out yet. I think we don't really know the true potential of what the sensors that we have, like magnetometers, accelerometers, across every single device and every single IoT product today. So I think what you're going to see is even more functionality and innovation coming by products that hadn't normally used sensors, now looking for how we could possibly implement them into their designs.
Is Freescale planning to launch any new sensors apart from the conventional accelerometer, gyroscopes, and temperature sensors?
Well, I can't say what we have coming out because that's confidential, but I can tell you we're working very hard on a lot of very innovative technologies around sensors that you'll see coming out in the next 12 months. And they'll be industry-leading and very groundbreaking technologies. So that's all I can say on that note.
What are the key challenges that you face in sensors development related to the IoT space?
I think power consumption is one, because sensors are generally scattered. Multiple sensors will be scattered in any one product or in multiple products in your home, and they need to run for long periods of time without being connected to power. I think the other one is size. I think the ability to have an extremely small accelerometer, an extremely small magnetometer, gyro, and integrate that almost like you wouldn't even think about integrating because it's so small into multiple devices. I think that's technology that's going to be the next step for sensors. I think in terms of other sensors, other types of sensors, I think what you're going to find is there's going to be multiple combinations of sensors that even exist today, creating new technologies.
How do you see the IoT market space in Asia when compared globally?
Oh, could you repeat that question?
How do you see the IoT market space in Asia when compared globally?
So what I see in the IoT space in the US is a lot of focus on efficiencies and for collecting more around efficiencies of how economic efficiencies. And so what I mean by that is parking meters in San Francisco or parking meters in New York. I believe there's $1.8 billion collected from parking meters in New York every single year. And so what the city is trying to do is they're trying to optimize those parking meters to get the highest possible revenue and also be the most efficient for people using them. So that's an example of efficiencies around pure money creation or an LED lighting and the ability to turn on and off LEDs in the actual infrastructure. What I find more in China or in Asia is more personal IoT applications being used for personal use, like in the home, or for the personal wearables, and more for the actual individual. And I think that's just the different pace and focus for the different governments as well as consumers in those two different locations.
According to you, which is the fastest growing IoT market or the business segment?
So I think the fastest growing IoT, I'd say, region would be the United States at the moment. I think if I look at the fastest growing IoT segment, I would think the actual industrial segment is going to be the fastest growing, because a lot of what we see is Fitbits and we see Nest devices, which is growing very, very fast. But I think the things we don't see is factory automation. The ability for huge factories making automobiles to be completely automated and adding efficiencies. Aeroplanes to be able to actually have in the engines to be able to have more fuel efficiencies. Like really in industrial-based devices is where we're going to see the biggest pickup, because they're the biggest number of dollars to be saved through efficiencies by using the Internet of Things.
Based on the market segment like automobile or industrial segment that you mentioned, what are the top 5 applications according to you that you rate would see the IoT market space again growing in the...
Yeah, so I think it's an interesting question. The 5 segments that I would see, if I look kind of departmentalized complete segments, if I look at just automotive and pick one from automotive, I would say the ability for a parking assist, at least in the near term, and I'd say ADAS, so basically the ability to have advanced driver assistance services, they would be the 2 very near-term huge increases, I would say, of technology in cars. And to kind of give you an example, we were talking earlier about Mercedes and BMW implementing, full automated car. We're still not there yet, but the ability to continually increase the driver assisting capability to the point where you can recognize where cars are coming and it warns you, as well as the ability to park a car. I know my wife is very excited about the ability for her car to park itself. She doesn't like parking, but the ability to have more parking assist will reduce accidents, will reduce save lives, so that's a huge area of focus. And that's a real, we see that technology being implemented in our end customers today, which will be available in about a year and a half.
So apart from automotive, what are the other 4?
Yeah, if I look to the home, I think the biggest technology that I think needs to happen before everything else happens is the compatibility of different devices. I think you have companies like Nest, again I've mentioned Nest before, but Nest creating different really communication protocols like Thread protocol that enables multiple different wireless standards to be able to communicate off the shelf with each other. I think today if you bought 5 products that are that are going to be home automation IoT products for your home, they probably won't connect very well, and you'll probably have to connect to each one of them. The ability for all of those to connect to a gateway and you to control it with one control, that's what the next technology is for me going to be based in, like a Nest device that's more like a gateway than it is in the actual end products in that home. And if I look at really on the smart city, I think lighting is one of the easiest and very most easy to implement technologies that's going to happen next. Because a lot of the lighting that exists today, which still exists today, is not LED. And not only not LED, but not connected to the internet. The ability to turn on and off and be able to change very easily lighting in streets is a multi-billion-dollar savings if you can connect them and if you can exchange traditional light bulbs with LED lighting. And I think that's something that we've already seen happen across the world, but there's a lot more growth there.
How do you see the consumer wearable market in Asia Pacific region?
I've actually been watching it since I've been here. I have a Garmin activity tracker, and I've been watching for people if they're wearing activity trackers, just as an example of a wearable, and I haven't seen it. So I don't know if the activity tracker component of wearables has caught on yet. I don't notice, I should notice, but I don't notice, which is the amount of iWatches that they've sold in Asia versus the rest of the world. But I feel that it's probably not going to be as much as what's happened in the US so far. I think the adoption of wearables has been more prevalent in the US so far. I think because people have gotten used to it, it penetrated there earlier. A lot of the technology has been originated from Silicon Valley or in the kind of New York or Austin or some of the big kind of startup hubs, because most of these devices are coming from startups initially. And I think it's just getting to Asia now. So I think, when I look at activity trackers, if I look at heart rate monitors, I think it's a lot to do with health, and I think it's a lot to do with monitoring. I think the US has been the first place to at least to use that so far.
Talking about the component part, like as the size of the products are getting more smaller and smaller, it's shrinking. Power consumption has always been a key point of discussion. Always active mode, like in the smartphones and the wearable devices, always have sensors with always active mode. So what are the key changes that are being happening in this particular development?
So one of the things that you can do to reduce power consumption and size is integrate multiple devices on the one chip. So you don't have to go from chip to chip, and that takes power to go and basically process something, go talk to a power management device outside, or go talk to memory or flash outside of the device. And it'll also take space because they're placed beside each other. If you integrate them onto one piece of silicon, and that is where you save power, you save price, and you also save size. And we've just released at Freescale Technology Forum about a month ago a new technology called SCM. And basically what that does is that integrates multiple different components in die form on the one device. And so what I mean by that, our first product we've brought out is taking an application processor with power, with flash and external memory, as well as 102 different components like resistors, capacitors, all on the one piece of silicon. And you're basically integrating everything. Not only is it lower power, lower price, and smaller form factor, but we can actually then mix and match different technologies and create those products within a 2 to 3 month period, because we're taking existing technologies and integrating them into a very small form factor. So I think that, at least as one of the steps, is going to be one of the steps to get smaller, lower power and lower cost. I think the second component is process technology. Is being able to get to lower process technologies, and when everything becomes smaller, it takes less power to power it, and it also then is a smaller form factor. A good example is the KLO2 or KLO3, which is the smallest ARM-based microcontroller in the world, which is a Kinetis-based device from Freescale, which is about 1.8 by 1.8 millimeters in square, and that basically has about 48 megahertz of performance, all squeezed into something literally the size of a dimple on a golf ball. It fits right into the size of a dimple of a golf ball. And that's a lot to do with process technology, but also packaging technology in that case.
I just have to stop. Okay, according to you, what is the key component, or it can be more than one component, that is changing the face of IoT?
That's a good question. I think the key component that's changing the face of IoT is kind of back to what I mentioned earlier on, which is the ability for multiple different connectivity standards to talk to each other. I think there's multiple different things that will change IoT, but at different phases of IoT. So unless you can connect Bluetooth, wireless LAN, Wi-Fi, Zigbee, unless they can actually work together, then you're never going to have a true IoT experience. You're never going to have people happy with the convenience element of it. You may have people happy with the money-saving elements of it, but the convenience factor is something that is going to really drive the IoT adoption. So unless that happens, and that's the first phase, I think what has to happen very much at the same time is the integration of security and the ability for people to integrate security easily. Because a lot of IoT devices are coming from, or products are coming from startup companies. Startup companies focus on functionality for differentiation and connectivity. So they don't focus on security today because it's not necessarily the easiest thing to implement. So the technology that has to happen, which is Freescale spending a lot of time on, is security capability for tamper protect and encryption that's easy to implement and doesn't cost incremental dollars to the overall design. So those are the two big things that I see for real adoption. And I think if I look at the third, which will be the next phase, is really how we use the analytics that we're gaining from these devices. We've just touched the tip of the iceberg in terms of how we actually use all of our household devices. And to give you an example, just the propeller blade in an aircraft like a 777 Boeing, it captures 1 terabyte of data every minute. So we don't even have the tools today to understand what we can do with that data. But what we do know, one of the components of data we've been able to capture from that is that you can reduce fuel efficiency by 30%, 30% on one flight based on changing the speed of that propeller to be efficient to keep the flight directly in line on its flight path. Now, that is just one example of the things we can learn from analytics, and I think we're just touching. I think data scientists, if I could go back to university right now, I would be studying data science.
What are the key challenges or the perceived threats related to IoT?
I think the challenges, like before, is going to be a lot of the interoperability, and that's one of the, I say, the challenges to IoT. I think the biggest threat is back to what I mentioned as well, is security. Because what's happening today is people are seeing the convenience factor in a lot of the IoT devices that they see, even in your car and at home. But really, unless you have security integrated into them, there's going to be one point that security becomes very visible, where people's homes are being broken into. People are capturing images from people's home video security systems. People will gain access to people's cars and press on the brakes while they're driving. And we've already seen examples of that today with GM's 2009 Impala. Basically, the government, DARPA in the US, actually did some tests and were able to break into a vehicle while it was driving through a wireless connection through OnStar and place the brakes on without the driver wanting to. So I think when you start seeing a lot of the safety concerns and the security concerns is when really people are going to really question the viability of the Internet of Things, unless we act fast and actually implement security into those devices now.
What are the plans of Freescale to tackle competition from other leading players in MCU and sensor segment?
Yeah, I think the combination actually of Freescale and NXP in the upcoming merger is going to put us in a position of pure strength. And what I mean by that is we'll be the number one microcontroller provider in the world. Being number one gives you a few things. If you're a growing company and if your company is doing very well, you're taking that leadership and reinvesting it into the future. What you also have when you're the number one MCU vendor in the world is you're supplying microcontrollers to all the top products and customers in the world. And what you do from that standpoint is you learn how to make even more innovative microcontrollers. You learn how to innovate even more around the core technologies of microcontrollers, because you're talking to all of the people dreaming up the best ideas for the next generation. And so having access to all of those thoughts and visibility to the future will keep us being number one in the future and allowing us to continually innovate in that space. When I look at sensors, I think Freescale not only has sensing technologies in the consumer or industrial world, we also have that in the automotive world. And we'll also be number one in automotive when we combine both companies in Freescale and NXP. So again, it's kind of back to the same concept. We're talking to the leading providers of products in this space, and we're learning from them to be able to create and innovate on new products for sensors for automotive as well as for industrial and for consumer.
What will be the key marketing strategy of Freescale for promotion of IoT solution in Asia Pacific region?
So you're sitting in one of them. The IoT truck is a good example of how we're able to actually bring IoT technologies and functionalities as well as the secure, and I'll talk a little bit about the secure awareness to our customers. So this IoT truck is just one of the components of what we're driving as an integrated marketing campaign. And what we're doing with the IoT truck is not only bringing it, I guess at the end of this year, if we continue this rate, there'll be something in the range of 500,000 people who will come through this truck. What we do in every location is we run security training as well at every stop that we go. So what we're trying to do is educate a lot of our customers, future customers, and even university students on how to implement security into embedded designs. So that's not only the awareness of all the technology with 100 demos that's available and kind of cutting edge functionality, but also educating people on how to implement security capability for their embedded solution. So that's one of the things that we're doing. Other things that we're doing is we're collaborating with universities and governments to be able to ensure that they have visibility to the technology that we have. So for some of the challenges that they may have technology-wise in their segments or in their functions, we're bringing them solutions with the potential of what we can provide for them. A good example would be things like what I think NXP has done very well, which is on smart cards and passports and NFC technology, is really talking to the governments about the possibility of what that can implement and the convenience, and then all the banking cards implement those. So it's really trying to solve solutions not only from the customer standpoint, but from the customer's customer.
How do you see the IoT market in India and China by end of 2020?
What I see is a lot of the IoT, as I mentioned earlier, has been driven by startup companies. I think Gartner says by 2017, 50% of IoT products will come from startups, and I firmly believe that. If I look at India and if I look at China, there is a huge amount of startups. There's a huge revolution of technology and companies creating new technologies in both of those countries. I see China in 2020 and India driving the Internet of Things, driving the functionality and the innovation that happens around that market, because of the acumen and the innovation that's happening in these two places.
How does company position itself in the IoT space when compared to global players?
So Freescale has quite a unique positioning, and also, and I'll mention Freescale and NXP because that's a very complementary portfolio, is what we have is we have not only all of the microcontrollers and the application processors at the end node, so in your home, in the factory, in your car, but we also have analog sensors in that space. And then when you move to the gateway, we have all of the processors, the analog that are actually in the gateway, as well as the cloud. So in the cloud and data centers on the edge networks, Freescale is 51% market share in those spaces, which basically allows those now, when we combine, to be number one in microcontroller for the end node. We're going to be number one in application processor or network processors for the gateway, and then number one in the network, really the edge network communication processors. So we're dominating each different area that an IoT transaction has to transfer information all the way through from edge to gateway to cloud, and we're in every single product that goes through, or we could be in every single product that goes through that Internet of Things transaction. Now, why that's good is because, first of all, we understand the ability to hand off information from one product to the other through communication, but also the security. We don't just secure a device, we secure a whole IoT transaction, and no other company in our industry can do that.
One last question. How do you see India in the IoT market? And is it the only market where Freescale wants to increase the sales, or do they realize India is a global marketing platform? Because with the growing number of independent captive design houses in India, so how does it actually?
So where we see India as an Internet of Things enabler is in multiple different forms. India is very well known for its software expertise and innovation, and I think the biggest challenges inside of the Internet of Things is on the software side. I mentioned the interoperability between different devices, even the applications that are running on multiple different devices, and the analytics that happens on those devices is all software based. India is a hive of activity for those different technologies, which really means that India is the leading place for technologies around the IoT. A lot of the different companies around the world outside of India are creating the hardware platforms, where India has a huge opportunity to excel in really the most valuable portion of the IoT, which is the software and the analytics component of it. I think if I look to India as, is it an important market for the IoT? I think for Freescale, a large portion of our business is actually designed in India. A large portion of our business, meaning our customers, is actually designed and developed in India and then manufactured in different places. So it's not a manufacturing hub, but a lot of the actual development is being done in India for a lot of our products, whether it be for in the cloud, in the gateway, or the end node. A lot of the active development that make a lot of these IoT products differentiated is already happening in India, and I think that'll happen even more and more as time goes on.
Okay. Thank you.